Okay then, so going through the Year 10 mock paper, starting with question 1. I've already put some notes on so that you can think about the meaning of each of those keywords. So running through the actual answers. Question 1, using only the numbers in the following list, write down a factor of 96. A factor divides into a number exactly with no remainders. So 96 can be divided by 32. And 32 goes into 96 3 times with no remainder. A cube number multiplies by itself 3 times. For example, 2 cubed is 2 times 2 times 2. The number we're looking for is 27 from 3 times 3 times 3. A multiple of 8.5 will be the 8.5 times table. 8.5 times 1 is 8.5. 2 lots of 8.5 would be 17. 3 lots of 8.5 would be 25.5. And 4 lots of 8.5 would be 34. A prime number has no factors except for itself and 1, like the number 13. So 26, no, because 2 is a factor. 27, no, because 3 is a factor. 2 goes into 28. 29 is a prime number. 10 and 3 go into 30. 31 is a prime number. 32, 33 and 34 can all be divided by either a 2 or a 3. I've grouped them together so that you can see that 9g here and minus 2g here must go to make a total number of g's. That would be 7g, because you take them away. And minus 5f plus 3f. If you start off on minus 5 and you go up 3, you'd go up to minus 2. In part B, the 3x is going to be 3 multiplied by minus 2. The 4y is going to be 4 multiplied by 4. This is going to give you a minus 6 plus, from the plus here, 16. And minus 6 plus 16 is 10. In question 3, I've already written down 5 squared, which is 5 times 5. 2 cubed, which is 2 times 2 times 2, which gives you a total of 8. And then 25 times 8 will give you 200. In part B, 3 6s are 18. But because you have a decimal place in the first number and a decimal place in the second number, pardon me, it's 18. Decimal place in the first number and in the second number, you actually have 2 decimal places in your answer. This subtraction has to be done column by column, and to start off with, 0 take away 5 you can't do, so you have to borrow. 10 take away 5, 6 take away 2, 8 take away 5. And on the last part, these fractions need to have the same denominator before you can actually subtract them. That one's already 7 out of 8. So if I double this one, top and bottom, to have a 2 out of 8, and I can take them away. Question 4 is multiple choice, but they will always give you a good looking wrong answer to try and confuse you. So if you worked out the area to be base times height 240. Because you forgot to divide by 2, the answer will be there waiting for you. But when you divide it by 2, 120. Part B, the angles in this triangle add up to 180. If that's what they wanted, it's there waiting for you. But you need to work out one individual angle, the value of x, one individual angle. So if you can see the 5x, the 3x and the x, that's 9 x's. So 9x equals 180 and 1x will only be 20. And for the volume of this cuboid, you need the length times the width times the height. If you mistakenly thought that was an adding up sum, they'll put the wrong answer there to confuse you, so be very careful. 5 2s are 10, 10 3s are 30, so 30 meters squared, cubed. Question 5, very similar to the last one. We have to make our own sum, our own addition sum, and the total will be 180. So 6x this time is with 180, 1x is only 30, but that's not the end of the question. It says find the sizes of all three angles. So the one angle is 30. The second angle would be 2x, which is 60, and the third angle in the triangle would be 3x, which is 90. So this one has 3 answers. 3 steps for question 6. First step, look at the x's in the left hand and the right hand side of the equation, and the smallest number of x's you can remove is 2x. So to remove 2x, we actually subtract 2x on both sides. Then, because of the minus 4 in the equation, I add on 4 to both sides. And then the last step, because of the multiplying 5, would be to divide by 5 both sides. Question B, to multiply out that bracket, the 2x has to be made 3 times bigger, and the 7 has to be made 3 times bigger, and the equation is 6x plus 21 equals 9. Because of the plus 21, I'm going to be taking away 21, so 6x will be minus 12, and then because of the multiplying 6, I need to divide by 6. How many 6's in minus 12? Minus 2. Question 6 is multiple choice. The minus sign here has absolutely nothing to do with the negative answer. The minus sign here is all to do with it being 1 over, and 2 times 2 times 2 on the bottom of that fraction is going to give you 8. No real clue I can give you for question 7c, other than anything to the power of 0 is with 1. So it's just 1. Question 7. If the input is 4, that means 4 is going into this equation. Then you need to take away 7. Then you need to multiply by 3. 4 take away 7 is minus 3. Minus 3 times 3 gives you minus 9. Part B, if 15 is the actual output, you've got to work backwards through this function machine to find out the number to go in. 15 divided by 3 is 5. 5 plus 7 makes 12. The last part in terms of algebra, because this part of the equation has to be done first, n minus 7 in a bracket makes it priority. Then you want that multiplied by 3. The n minus 7 in the bracket is the priority, but quite often the multiplying 3 will be put at the front just to keep things tidy. A 144 needs to be written in prime factors. The product of prime factors in index form tells me that it's going to be in powers. 144 divided by 2 can be divided by 2 again, can be divided by 2 again, and again. 2 won't work anymore, so I've got to move up so I can try 3s. And as soon as I get to a prime number, I stop. So 144 can be written as 2 to the power of 4 times 3 to the power of 2. Product of prime factors in index form. So I'm going to put that down by here to help me with part B. And I'm actually going to add to part B a 5 to the power of 0. So that I've got 2s, 3s and 5s, 2s, 3s and 5s. Every equation is the same. Every prime number is written in the same 3 factors. So if I'm looking for the highest common factor, I'm going to take the lowest choice of the 2s, 2 to the power of 2, the lowest choice of the 3s, 3 to the power of 1, the lowest choice of the 5s, 5 to the power of 0. 2 squared is 4 times a 3 times a 1, 12. For the lowest common multiple, I still need to use those 3 numbers for the 60 and those 3 numbers there for the 144, but this time I'm looking for the highest mix. So I look at the 2s and I take 2 to the power of 4. I look at the 3s and I take the 3 squared, and I look at the 5s and I take 5 to the power of 1. 2 to the power of 4 is 16. 3 squared is 9 times by 5. (16) times by 9 times by 5 would give you 720. Question 10. We're allowed 3 significant figures. So we're allowed these 3. This is my cutoff point. And the 53 here is big enough to make you round up. So 80,953 becomes 81,000. In question C, I'm allowed 2 significant figures. These are both non-zero. First 2 significant figures non-zero after the decimal point. So my cutoff point here. The 1 this time isn't big enough to make me round up. So I stay with the 74. In question 11, we're looking for a different rectangle with the same perimeter. The perimeter of the first one, if it's going to be 3 by 5, the perimeter of the first one is 3 plus 5 plus 3 plus 5, which makes 16. And if we're going to draw a rectangle with the same perimeter, we're going to need it to have a perimeter of 16. So if we make it a 6 metre by 2 metre, the perimeter will be 6 plus 2 plus 6 plus 2, which is 16 metres. In the last part of the question here, the original rectangle was 5 by 3. The new rectangle is to be twice the size, double the length, double the width. So 5 by 3 had an area of 15. 10 by 6 has an area of 60. Area is length times width. The question says, does this mean that the area has been doubled? And the answer is actually no. The area has been multiplied by 4.